Hello students in Introduction to Statistics at Salt Lake Community College. This video will give you a brief overview of what you will need to do for the first part of the tuberculosis data project. Before I go into the 6 sections of part 3, I want to make a note yet again that you should not include the directions of the project in your submission. Make sure that you reword anything that you have so it's clear to the reader what you are doing. For this part of the project, we will be working with quantitative data. Specifically, we will primarily be focusing on the total TB incidence values that you collected in part 1 of the project. First, for section A, you will be creating a table in your document that includes those 10 values for total TB incidence. In order to do that, we can open up Word or Google Docs. Go to Insert tab and create a table. Note that we collected the TB incidence rates. We also collected the success rates and the cohort sizes. We only need total TB incidence in this case, as well as the name of the countries. So we should only need 2 columns. Those 2 columns should have the countries, or country, and total TB incidence. And you can list your countries. Maybe you have Afghanistan, maybe you have Mexico, maybe you have Guatemala. And then indicate their total TB incidence. These should typically be whole number values, though if they're small enough, they sometimes have decimals. For example, something like 120, 85, or 6.2. I'm making all these numbers up. Make sure you include this table, and you can reformat it as you will if you would like to make it nicer. Something like this, and you can move it around your document. You will create a table for all these countries. I have 3, 4, 5, 6, 7, 8, 9, and 10. So make sure you have all 10 countries there and the total TB incidence values. You will then take those total TB incidence values and put them into GeoGebra. If you open up GeoGebra, you likely get a screen like this, and we need to go to the spreadsheet, which we can get to by either clicking the top right button on either of these sections, either the input or this plane. The top right section, and then these 3 dots to make a spreadsheet. Or if you just open GeoGebra, you might see spreadsheet as an option on the far right. With this spreadsheet, include all 10 of your values. I will make up some values here. So 75, 83, 110, 42, 13, 17, 29. Let's do 216. Let's do 74 and 88. Okay, so I have 10 values here, whatever your 10 total TB incidence values are for your countries. And then select that column that you have your values, go up to the top left, and create one variable analysis. You are tasked in this section of the project to create an appropriate graph for this data. Specifically, because this is quantitative data, you want to make sure that that appropriate graph is likely something like a histogram, a box plot, or a dot plot could suffice. I would suggest either a histogram or a box plot. For section A, you will be including a picture of whatever graph you decide to select, but you'll also need to make sure that they include values on the axes. For example, if I wanted to use this box plot, I don't have any names on the axes or a title for this. So if I want to use this, I can export it as a picture if I would like, and save it appropriately. Or I can take a snippet using one of your snippet tools. I'm on Windows, so I will use Snip here. Take this picture, and I can put it into an editing program such as Paint. If you are on Mac, you will likely be using something like Preview. You could put the picture in here and then create a title. Maybe this is something like Total TB Incidents in 10 sampled countries. Maybe that's my title, and I can increase the size of that. Sampled countries. So I can make a title. I can also put a label on this axis. This should just be total TB incidents. And include a picture like this into your project. When you have this edited in either Paint or Premiere are the two editing programs that I would suggest. You can select all of it, copy, and paste it into your document. And there we go. Now I have my graph. Be sure to include labels on that graph itself. It is also possible to do this in Word if you would like. I just showed how to do it in Paint. That is what you're going to do for section A of this project. Make that table and an appropriate graph for the quantitative data. For part B, you will then describe the shape of your graph. You will likely either say that it is skewed left, skewed right, approximately symmetric, or uniform. And based on that shape, make sure you identify appropriate values for both the center and the spread. So center and spread. And indicate them both by name and value. For an example, a value that is sometimes used as spread, although it should not be because it is not a very good measure for either skewed or symmetric data, would be something like range. If I calculate the range and say the range is 32, then that's what I would need to report. I would both report the name of it, range, and the value of 32. Some of these values you may be able to find in GeoGebra. When you make this graph, you can go to the top right and select Show Statistics to get a lot of values, including mean, sample standard deviation, median, quartiles. You get a lot of values here, and some of these you may be using, depending on the shape of your graph. With these values as well, for section C, you will be trying to show if there are any outliers for your data for total TB incidents. You will need to justify that by showing your work to compute both upper and lower fences. That means show the work that you do, the math that you calculated to find the fences. Don't just report them as the lower fence is 10, the upper fence is 400. Make sure you actually show how you calculated those. And if there are any outliers, identify them by the value of the outlier, the numeric value, and what country that represents. For example, in my data set, if I find that Afghanistan is an outlier, I will need to say that 120 is an outlier based on my fences, and you should explain why. And I should also indicate that 120 corresponds to the country of Afghanistan. For section D, E, and F, you are going to start to check conditions and create confidence intervals and hypothesis tests. For D, you are going to check the three conditions for making either a confidence interval or hypothesis test for mu. Those conditions should be the same for either confidence interval or hypothesis test. You should be checking randomness, independence, and, since we're working with quantitative data, you should confirm the central limit theorem, which either says that we know the population is normally distributed or the sample size is large enough. For the purposes of this, particularly for checking if the sample size is large enough and also to confirm independence, we suggest that for the purposes of only step D, consider the sample size n as the total cohort size of all 10 countries combined. In section or part 1 of the project, you gathered all the cohort values for the countries. That's how many people were sampled for that. take all those cohorts, combine them together, and use that as a sample size for the 10 countries. That'll make it a little bit easier to confirm both independence and the central limit theorem. Note, this is the only time that we'll be using that for n. For both E and F, we are going to use 10 as the value for the sample size. For E and F, compute and interpret a 95% confidence interval for the sample of total TB incidence values from section A. So for that, we are going to need both the mean and the standard deviation. In my spreadsheet, I have the mean as 74.7, and because this was a sample, I'll use a sample standard deviation of 59.34. You can be more precise if you'd like. And I should be using those in GeoGebra in order to check a confidence interval. To make a confidence interval, we can open up Probability Calculator and go to the Statistics section. Because we're doing quantitative data, and we are doing this for a confidence interval, we'll be going down to the Estimate section, and we're only doing one mean, so we'll be using t-estimate of a mean. Here I'll plug in my mean of 74.7, sample standard deviation of 59.34, and a sample size of 10. Make sure you use 10 here, not the total cohort size. This should give me my confidence interval, my lower and upper limit of this confidence interval, and I should include a picture of this in my document as well. So be sure to take a snip of this as well, include it into your document. Make sure we don't just compute the interval, you also interpret. So make sure you say something along the lines of, we are 95% confident, or there is 95% confidence that, etc. Lastly, for part F, you'll be creating a hypothesis test for the same information. However, you're going to be checking against the CDC's claim that the global incidence rate of TB is 132. You are going to determine if that global incidence rate of TB in the world is different than the reported value of 132. You will be using the same mean, standard deviation, and sample size that you used in E, and make sure that you follow all steps for hypothesis test. That means include both the hypotheses, the null and alternative, show the work from GeoGebra. In GeoGebra, you should be using t-test of a mean for hypothesis test. Make sure you include the picture that you're working with and change the value for the null hypothesis. Identify what the test statistic is, the p-value, select a value of alpha, and make a conclusion in context about what your data says about the claimed global incidence rate for TB of 132 people. Note that there are 2 videos here for GeoGebra that link to videos from the Introduction to Statistics YouTube channel that can help you out if you need more help with working with GeoGebra. That should be everything. I hope this helps when working through part 3 of the tuberculosis data project.